This is IED Activity 5.5a, CAD Model Features, Part 1. Problem number 3. Problem number 3 is a hole practice problem. In this problem, we will be working with the circular tool, the point tool, the circular pattern tool, and we will share a sketch through the browser. We will extrude, and we will create 5 different types of holes. So let's get started in Inventor. I'm going to create a new part with a new sketch, 2D sketch that is, on the XY plane. I'm going to use the origin, so I'm going to leave everything here. I am going to click out, zoom out 2 clicks here. That should be enough. We'll see before I get started so that my image of my object will fit on the screen. I'm going to create a circular pattern, or circular part here, that has an extruded depth of 1.5. This circle is 4 inches in diameter with a depth of extrusion depth of 1.5. So I'm going to go ahead and create that. Click my circle tool, come out, type in 4 inches. Fits barely on my screen. I'm going to zoom out one more here, and that's all I need. Just a 4-inch circle. I'm going to finish that sketch. Click on my home view, and then extrude that object and that circle 1.5 inches. So I have my part that I'm going to do all my holes in. So the next thing I need to do is right click on this front surface and start another 2D sketch, or another sketch, excuse me. And in order to do this, I'm going to place 5 points on this circle this circle that we'll drill our holes in. Each of these holes are going to be 72 degrees apart, and the circle that I'm going to place these points on is 2.5 inches in diameter. So let's go ahead and get our circle tool. I'm going to click on my circle, the origin, and type in 2.5, which places my circle. And the next thing I'm going to do is I'm going to cancel that circle command. And at this point, I want to, and press escape a couple times here to get out of all my commands. Click on that circle again, and then click on the hidden or construction line, command tool up here. So now I've turned that circle into a construction line because it's not actually going to be drawn or part of the finished part. It's just a reference for me to place the 5 points around for the center points of those holes. So let's go ahead and click on the point tool, and I'm going to put a point right where the y-axis and that circle come together. I can tell it's there because I've got a coincident constraint, and I can see the green tips of the point crosshairs underneath that coincident constraint. I'll press escape to get out of that 2 times, and you can see if I take my mouse, it'll pop up white when I get close to that point. So let's go ahead, and instead of measuring 72 degrees for each one of these, let's just use our circular pattern tool so that we can automatically create that circle pattern all around this circle, this 2.5 inch circle, and save us some work. So I'm going to click on the geometry of that, which is that point. It wants to know what am I going to rotate that around, what axis. I'm going to click on my construction line. And right now the number I have here is 6, but I only need 5, so I'll change that 6 to 5. And you can see now I've got a yellow X, 1, 2, 3, 4, 5 of them on my circle. That is a construction line. And if we do our measurements, 360 degrees is a full circle divided by 5 gives us 72 degrees. So each one of those is 72 degrees apart. Perfect for what we need. That's all we need on this sketch. We're going to finish it, and we're going to use those points to create holes. In our 3D model tab under modify, we have the hole command. So I'm going to right click on that first hole and click on hole. And by doing that, it's going to bring up the hole menu. We're going to do a straight through hole. That is, again, all the way through here, 2 different types, showing you it's a straight through hole being drilled down. And the distance is what's going to be the kicker on this one. We don't want it to go a certain distance. We want it to go through all. So it's going to go the whole way through. And the diameter of this hole right here is 0.25. So I'm going to click on whoops, 0.25. I'm going to click the OK button. I'm going to try to get that out of the way, but it's not going to. And you can see I now have a hole that goes the whole way through. That is a 1/4 inch in diameter. So the next hole we want to make is a 3/8 of an inch, 0.375 hole that goes the entire way through, but has a counter bore that is 3/4 of an inch for a depth of 0.25 inches. So let's look at that a little more closely. What is a counter bore? Well, a counter bore hole, if we look at the cutaway, is a hole that has 2 holes to it. It has a hole that goes the whole way through, and then a second hole that only goes part way in. Its purpose is to hide the head of a bolt or screw so that it doesn't show or is just below the surface, so you can slide things across the surface and not have them get stuck on the bolt head as it goes by. So an example would be this lag bolt here. They've counterbored this down so that it comes down in and is slightly below the surface so that, again, if something smooth needs to be slid across here, it can be. So let's talk a little bit about this. Let's go ahead and create our next hole using our hole command here. As I go to my part, I notice that my holes are all gone, or my points are all gone, excuse me, and my circle. Well, that's not very helpful. So that's okay. We don't have to draw anything again. It's there. We just need to somehow get it back. And the way we get that back is we expand hole 1, and you'll see it has consumed sketch 2 as a child of it. So we're going to right click on it on sketch 2 with my sketch 2. I don't know what it is for you. And I want to share that sketch. And now it brings that sketch out and puts it back to life so that we can see it and continue to use it on the next few steps. So I'm going to now go back and I'm going to find my second hole, which is right here. I'm going to right click on it, choose my hole tool. And this hole is a counter bore. Counter bore is the second one down. So I'll click on that. And again, it wants to know some information. As you recall, we said that it's a 3/8 of an inch hole the whole way through. So here's where we're going to type in 3/8, which is 0.375. Or you could do 3 divided by 8. Doesn't matter. Either way works. It's going to go through all. The counter bore diameter is 0.75. So I'll put that in. And for a depth of 1/4 of an inch, which is 0.25. So everything else looks good on this. I'm going to go ahead. I've got the first one selected here. It's a simple hole. It's a counter bore, 0.75 outside diameter for the counter bore, counter bore depth of 0.25 inches, and the through hole diameter of 0.375. So I'll click OK. And I now have a counter bored hole that goes the whole way through. And if I rotate around and look at this, you can see it does make it the entire way. Click back on my home view, and I will move on to the next hole. The next hole is a countersink hole. It is a hole that is 0.375 or 3/8 of an inch that goes the entire way through, but it is countersunk with a 3/4 inch diameter countersink on an 82-degree angle. So let's see what that guy looks like. Here's an example. In the cutaway, you'll see I have my 3/8 inch hole going the whole way through with this beveled edge or tapered edge going all the way around that counterboard surface. Here's an example of how that would look. We have a screw or a bolt with a tapered edge that we want to be just below the surface that continues down through our material and comes out the other side. A real life example, this part here is threaded. Think of this as 2 boards coming together or 2 pieces of metal. We've threaded the bottom one, and we are going to screw this bolt or screw into that bottom one, and the pressure that's created on this beveled or tapered edge here at the underside of the head of this bolt will press down and be pulled down against the surface of this one over here, holding these 2 boards together, or 2 pieces of metal together. So let's go ahead and create that third hole. We'll right click on that hole, click the hole command, and it remembered some of our dimensions from the last hole that we did. Diameter of 3/4 of an inch. Well, that's correct. We do need a 3/4 inch diameter, but hey, it says this is a counter bore. We don't want a counter bore. We want a counter sink, which is this last one down here. I think it, oh, here, now it'll do it. Countersink, so I'll click on that one. So now 3/4 inch diameter for the countersink on an 82-degree countersink angle for a dimension of diameter of 3/8 or 0.375 inches going the whole way through. And then once again, this is a simple hole that has been countersunk. I'll click OK. And you can see this looks slightly different as I rotate this around compared to the other hole, but it does go the whole way through. Our fourth hole is a little different. It is a 1/4 inch, 20 thread per inch, 1B threaded hole that goes 3/4 inch in depth. So let's look at this a little more closely. What would this look like? Well, this is called a tapped hole. A tapped hole means it's threaded. And as you see here, we have a series of holes on this plate that they're showing here in the image on the left. And this device right here is called a tap. It's a series of teeth on like a drill, kind of a drill-like bit that is pushed and rotated in. And as it rotates and goes down in, it cuts teeth into the material that it's going into. So these are have already been cut by the tap. It's circulated down in there and tapped those out or scraped those out. And what you have is this part down here on our right image where the screw threads are in contact with this bottom plate here. That's a tapped hole. So the tapped hole they've asked us to do from that image, let's go back and look at that, is that this is a 1/4 inch, 20 threads per inch, class 1B bolt that is 3/4 inch deep. So that hole is going to be a little different than the ones we did before. So I'm going to right click on point number 4, select hole. And this is going to, when I go to load the tapped hole images, it's going to take a little bit of time because it's going to load all these various thread types. So the third hole over is a tapped hole. So I'm going to check on that one. Luckily, it remembered. It's got them all loaded, so that was quick. Yours may take a minute or so for it to load all the different thread types and bolt types. So we need a ANSI unified screw thread. It said it was a 1/4 inch by 20 threads per inch. So I'm going to change that to 1/4 inch. Now I've got my designation over here of 1/4-20, which means 1/4 inch diameter bolt with 20 threads per inch, UNC, Unified National Course. It is a tapped hole. It is a class 1B, not 2B, so that's going to change a few things. It does not go the full depth. It only goes a certain distance. On their instructions, and I'm going to go back to that, it says it goes 3/4 inch, it goes a depth of 0.75. So we're going to have to change that on ours. Actually, it's already there for us. It's 0.75. It is not a countersunk hole. It is a tapped hole. So we are just putting in a regular through hole here, which is drilled. And it only goes down 3/4 inch. Does not say whether or not it's flat, so let's check and see what they tell us on that. They didn't give us whether it was flat or rounded. I'm going to go with flat on the drill point. I want it to come down to be flat down there. So 3/4 inch depth, tapped. You can tell it's tapped by that symbol there. Comes all the way down. We've selected that one. We're good. We do want the threads to go the full depth. We want them to go all the way down to the bottom of the hole that we're drilling or tapping. So we're good to go with that. So we'll click OK on that. Now, again, I told it to only go down 3/4 inch. So we only have 3 holes on the back because that one did not go the whole way through. I'm also going to zoom in on that. And if I zoom in on it, you can see it's created those threads in that material. So go back to my home view. That is a tapped hole that only goes 3/4 inch deep. Last hole. The last hole we're going to create, number 5, is called a clearance hole. And a clearance hole is used when you want the item, the bolt, or whatever it is that's going to go through, to not actually touch the material, but to pass through it freely. You might use it as a positioning pin, or as in this example I have here, it's the bolt going through and the bolt head on the top with the bolt or the nut on the bottom, but it allows those two parts to be mated without actually screwing into one of those parts. We're using the pressure of the bolt and the nut to do the work. So a clearance hole, if we look at that, the clearance hole is a regular drilled hole. It's a drilled hole, but it has a clearance. So when we go and put the information in, it's going to take a second here for it to load information. It's going to ask us what type of bolt we want to use. And if I look at my instructions over here while that's still loading, it says we're looking at a hex head bolt that is 1/2 inch diameter, size 1/2, with a normal fit. So ANSI unified screw heads, threads. They said a flat machine. Nope, we want a hex head bolt, and we want it to be 1/2 inch. Fit is normal. And what that does, and we do need it to go the whole way through, it's through all. So this one's going to go the entire way through. And if you notice here, it automatically put that, yeah, there, I can move that out of there. Put a clearance dimension on here. So the part that's coming in here is 1/2 inch, and it gave an extra 0.031 inches to the hole to allow for that part to pass through there without any obstruction. So I'll click OK to that, and it put that hole in, and again that hole goes the whole way through. And with that, we have put all 5 holes, all 5 types of holes in there, and this part is done. Please save this part as hole practice with your initials, and we will move on to our next drawing.